Hello and welcome to my first attempt at the inverted classroom of Calculus 2, in which what I would normally have lectured on becomes your homework to watch this video, and what I normally would have sent you home to do for homework, you will do in class while I walk around and give advice and comments, and I have high hopes for this. If it doesn't work, we'll go back to the old method, which is frankly much easier for me. But I think this is going to be nice. So today we're going to talk about differentiation. We're going to do a review of the differentiation from Calc 1, and let's just jump in. Let's say you have f of x is 5x cubed minus the square root of x over 4 plus 8 over the cube root of x squared plus 4x plus 2. This is a series of things added and subtracted. That means we can deal with each one separately. We can deal with constants separately. These are all basically constants multiplied by x's to various powers. Now, the second term, one might think one would, or the third term, one might be inclined to use the quotient rule, but it's not necessary at all. This is 5x cubed. The coefficient on this next one is 1/4, and then it's x to the 1/2 power. Then the coefficient is 8, and oh my goodness, let's see, we have x. It is in the denominator, so it's a negative exponent. It is squared, so the numerator is 2. It's the cube root, so the denominator is 1/3. X to the negative 2/3 plus 4x plus 2. And then the derivative, we use the old, multiply the exponent by the coefficient, and then subtract 1 from the exponent trick. Let me move this down a little bit. And we will say that this is 15x squared. Negative 1/4 times 1/2 is negative 1/8. X to the 1/2 minus 1 is negative 1/2 plus, it's not going to be plus, it's going to be 8 times negative 2/3, which is minus 16/3. X to the negative 2/3 minus another 3/3 is negative 5/3. 4x to the 1 times 4 is 4. 1 minus 1 is 0. X to the 0 is just 1. That goes away. And this is 2x to the 0. The 0 multiplies in front and goes away. And that is that. Let's try another one. Let's suppose we had g of x is sine of x times the cosine of x. I wanted to just sort of review product rule and trigonometric functions. The derivative is the derivative of the first, derivative of sine is cosine, times the second one left alone, and then plus the first one left alone, sine of x, times the derivative of the second one. The derivative of cosine of x is minus sine of x. So the whole thing turns out to be cosine squared of x minus sine squared of x, which is not 1. If it was cosine squared plus sine squared, it would be 1. But as it is, that's pretty much all we could do. I mean, yes, you could replace the cosine squared, because, you know, I'm talking about cosine squared of x plus sine squared of x is 1. That means that cosine squared of x is 1 minus sine squared of x. So if you wanted to, you could say this was 1 minus sine squared of x minus sine squared of x, which is 1 minus 2 sine squared of x. We don't have this problem as much in this class because we're not using a textbook, but there's lots of times where you look up the answer and you think you're wrong because the answer could be in very, very different formats. This answer and this answer are exactly the same. So if you and your partner get a completely different answer, you could be both right. Let's see. Hopefully you know that the derivative of e to the x is e to the x. I didn't make as much of a big deal about that with the little teddy bear who doesn't change as I could have. If you want to take the derivative of e to the something, like e to the 4x, now you have to use the chain rule. It's the derivative of e to the something is the e to the something times the derivative of the something. and the derivative of 4x, I believe we actually did that exact one just a second ago, is 4. So it's e to the 4x times 4, although most people are going to put the 4 first, 4e to the 4x, because you kind of need a little dot or something implying that there's multiplication here, but coefficients are pretty clear to be multiplied. Let's say we have y is the tangent of 5 plus e to the 10x squared. That's the tangent of something. Well, hopefully you remember, and if you don't remember, this video will remind you that the derivative of tangent is secant squared. So the derivative of the tangent of stuff is secant squared of stuff, which in this case is 5 plus e to the 10x squared. And then you multiply by the derivative of the stuff. Now the derivative of 5 is 0, we can ignore that. The derivative of e to the something is e to the something. And the derivative of that something, which is 10x squared, is 20x. Now we probably would ultimately put the 20x first and then the e and whatever, but this is the kind of answer I'm looking for. We will leave that as it is. Let's see. You need to know the derivative of sine and cosine and tangent. You should also know the inverse. Specifically, I want you to know that the derivative of sine inverse of x is, oh goodness, do I know it? 1 over the square root of 1 minus x squared. And the derivative of the arctangent inverse tangent is 1 over 1 plus x squared. This is not 1 over tangent. This is the untangent. This is the thing that undoes tangent. I don't feel like going through the whole proof of this, but these two things come up all the time in Calculus 2, so remember them. Another one that we did with sort of implicit differentiation was, let's say, y is the natural log of the secant of 8x. Well, what I want you to know is that the derivative of the natural log is the derivative of the natural log of x is just 1 over x. The derivative of the natural log of stuff, chain rule, is 1 over the stuff, secant of 8x, times the derivative of the stuff. Aha! I want you to know what the derivative of secant is. The derivative of secant is secant tangent. This one really throws people because you're going to have to take that stuff and put it twice. Derivative of secant is secant of secant tangent, and we leave the 8x alone at first, and then just once we have to multiply by the derivative of what's inside, which gives us 8. Now this is a little weird because clearly that goes away. And so the whole thing turns into just 8 tangent of 8x. Why? Well, because the natural log of the secant of 8x is really the natural log. Secant is 1 over cosine of 8x. And that is the natural log of cosine. I'm running off to the edge here. This is the natural log of cosine of 8x. You're going to hate me for this, but to the negative 1 power. Now this is not the uncosine. This is literally 1 over cosine. That's what secant is. And with a natural log, or any log, you can pull that exponent out front. This is negative natural log of cosine of 8x. And with another parenthesis, which the derivative of that, dy dx, is, the negative is just a coefficient. It's really negative 1 multiplied. Derivative of natural log of something is 1 over the something, cosine of 8x, times the derivative of that something. The derivative of cosine, as we've said earlier, is negative sine of the something, times the derivative of the something. And if you look, these negatives are going to cancel out, and sine over cosine is tangent. And that's why you get 8 tangent of 8x, or 8 sine of 8x over cosine of 8x, which is tangent of 8x. Again, there's a lot of different ways to come up with, I mean, what am I saying? There's a lot of different ways to represent a function. And so if you get one answer and someone else gets another answer, well, you might very well be both right. So never discount that possibility.